The internal structure of the Earth can be divided into three main parts, which are the crust, the mantle, and the core. One of our previous tutorials have given an overview of the internal structures of the Earth. This tutorial will expatiate on the Earth's crust, which is a part of the Earth we see every day. The Earth's crust is the outermost part of the Earth. It can be regarded as the shell of the egg. We are all familiar with an egg, a chicken egg maybe. The shell of an egg is very thick, definitely not. Same as the Earth's crust. The Earth's crust makes up only about 1% by mass of the Earth's internal structure. Yet, all human activities are done on the Earth's crust. That is the solid ground which we are standing on. There are 8 elements that are commonly found in the Earth's crust, and they include oxygen, silicon, aluminium, calcium, iron, magnesium, sodium, and potassium. The crust can be divided into 2 types based on its composition, thickness, and density. These are the continental crust and the oceanic crust. The continental crust is granitic in composition, having more feldspar and silicate minerals, otherwise called felsic minerals. It is thicker, about 30 to 70 kilometers thick, and older than the oceanic crust. Although thicker than the oceanic crust, the continental crust is less dense than the oceanic crust. The oceanic crust is basaltic, having more magnesium and iron, otherwise called mafic minerals. It is thinner, about 5 to 10 kilometers thick, and younger than the continental crust. The oceanic crust is denser than the continental crust. The continental crust is composed primarily of felsic minerals, while the oceanic crust is composed primarily of mafic minerals. The difference in their composition has been attributed to fractional crystallization of molten magma. The oceanic crust is thin and cold, obviously because of the ocean of water above it. When molten magma forces its way through the oceanic crust, it crystallizes rapidly because of the cold temperature, which gives limited time for fractional crystallization. But in the thick continental crust, where the temperature isn't cold, magma keeps forcing its way upward through cracks, and as it moves upward, the temperature becomes cooler. The higher you go, the cooler it becomes, thereby making some minerals such as olivine to crystallize and leaving a more silicate magma, which will form feldspar and quartz behind. Also, upwelling magma reacts with rock which it comes in contact with, and this changes its composition. We will discuss fractional crystallization of molten magma in details in future tutorials. Stay tuned by subscribing to this channel. The oceanic crust is thin and about 3 grams per cubic centimeter dense, while the continental crust is thick and about 2.7 grams per cubic centimeter dense. We'll go a little into physics here. Please hang on and don't get lost. Density is mass divided by volume. Therefore, one expects a thicker material to be denser. But temperature difference between the oceanic crust and the continental crust is one of the factors responsible for this density difference. It is said earlier that the crust is cold. Temperature is directly proportional to volume. That's Charleston. It implies that if temperature is higher, the volume will be higher, and if temperature is lower, the volume will be lower. Therefore, the temperature of the oceanic crust is lower, making its volume to be lower. Since the volume is reduced, the density will increase. Let us work a little mathematics. Assume the mass of the head is 10 grams and the volume is 5 centimeter cube. The resulting density will be 2 grams per cubic centimeter. Now, temperature lowers the volume to 2 centimeter cube. The resulting density will therefore increase to 5 centimeter cube. That is one of the reasons why the crust is dense. Another reason is because the crust is composed of mafic rocks. Mafic rocks contain high density minerals such as pyroxene and olivine and are thus more dense than felsic rocks, which contains more of lower density minerals such as quartz and feldspar. I hope you are not lost. If you feel there is any other reason why the crust is denser, kindly share in the comments below. Lastly, we'll talk about the lithosphere. It is regarded as the rigid part of the head. It is made up of the crust and the upper mantle. The lithosphere is broken into 7 main lithospheric plates, which are constantly moving. This continuous movement is called plate tectonics. How is the movement of lithospheric plate possible? We will discuss in another tutorial. If you have any question or suggestion, kindly drop in the comment box. Thanks for watching.